right, so shall we get started? Okay. Can the remote audience hear us?
Yes.
Great. Okay. Well, thank you everyone for coming and for attending in person and remotely today's AIFARMS Seminar. It is my pleasure to introduce Dr. Jinha Zhang as the speaker. Dr. Jinha Zhang is an associate professor in the School of Civil Engineering at Purdue University. He received his PhD degree in geomatics, civil engineering, specializing in computational science and engineering at Purdue University in 2011. He worked as a postdoctoral research associate at the University of Illinois at Chicago and Purdue University, and also worked as a faculty at Texas A&M University Corpus Christi from 2014 until he joined Purdue University in 2019. Dr. Zhang is noted for his work in the development of unmanned aircraft system-based high-throughput phenotyping system for agriculture applications. He's also known for developing algorithms to process UAS data for feature extraction, data fusion of hyperspectral and full waveform LiDAR data, vegetation structural analysis using LiDAR data, high performance computing for advanced remote sensing algorithm development, and also for the development of WebGIS software using free and open source software. I would like to add to this that I have personally gotten to meet Dr. Zhang through my involvement with the Ag Biodata Phenotyping Working Group that Dr. Zhang is heading. The goals of this working group are connected to the work that we have been doing as part of the AIFARMS Institute. I'm very pleased that Dr. Zhang was able to come today and deliver his talk, Seeing the Unseen Modular Open Source Ecosystem for Geo AI. And without further ado, please welcome Dr. Zhang.
Thank you, Anna. Thank you very much for a great introduction. And thank you very much for students, I guess, coming to this place in person. It's my great honor to have a chance to, share my one of most recent, passion about, what, my research group has been working on. And the title of this presentation that I named it as a Seeing the Unseen. I'm going to talk about why I'm just doing it that way. But this is going to be mainly about a modular open source ecosystem that we've been developing for the last couple of years, mainly to enable geospatial data science and AI development. And I'd like to acknowledge my co-authors for this presentation. Myself is at the top, as you can see. And there's another one, Benjamin Hancock. And I'm the one who is leading this project, but he is the one who is doing all this magic behind the scene. So he's the lead developer for this project. And Minyoung Zhang, she's a postdoc working in my research group, who's been instrumental to make this project happen. So I'd like to start my presentation with this quote that I mentioned about seeing the unseen. And this is not something that I came up with. And I heard about this quote in one of the other presentations that I was attending. And I just looked it up. And actually, there's a lot of books with this specific title. And the main idea of this quote that was introduced in the presentation was that, hey, do you remember the first time when you saw something for the first time? Something phenomenal. In my personal experience, we all learned about Grand Canyon in the books, but we saw the great pictures. But when I actually personally went there, saw it for the first time, this is something that I never imagined that is possible. And I still remember that great joy that I had when I first experienced it for the first time. So I'd like to start my presentation with one video
Yeah. Lani,
that we're going to watch together.
Look at mommy. Look at mommy. Ooh, look at eyes look so cute. Hello, Bubbles. Can you see? Wow. Lani, look at me.
Dad, she looks like Bubbles off of Trailer Park Boys.
Yeah. Show Daddy.
Really, but it makes it look sort of special.
Oh, you can see. She's like looking around.
Can you see that?
Lani!
Leave them. Don't touch.
Lani!
You need them on so you can see.
Honey, look at Regan. Can you see?
Lani!
Look at Regan.
So what I'm hoping at the end of this presentation is that you guys are making this face exactly, because I'm hoping that you're about to see something that you have not seen before. Okay? I'm going to turn my clock a couple of hundred years ago. This is about 600 years ago, and there's something we take for granted right now, but that was not available for everybody, which is text information. In those days, in order to access this text information, you need to be rich, and you need to have a lot of power, because you need to hire somebody to write something on the paper for you. Then you can consume this text information. That's the reason why you see this in a figure over here. There's people who is mainly, this is about Bible at the times. Okay, this is one of the oldest Bible they found. I think that this Bible costs probably tens of millions of dollars right now because of rarity of it. But the point I'm trying to make right now is that the text information was not available to everybody not long ago. But something magical happened about 600 years ago, which is Gutenberg printing press. To be exact, 1450. After this new technology has been developed, now generating this text information becomes so cheap. And now, in order to access this text information, you don't need to hire somebody to spend months and years to write on a paper manually. You can go to the bookstore, you can just buy it, right? And we may have forgotten this fact that because accessing this text information is so easy to everybody. So these handwritten books, we had such a huge revolution happen about 600 years ago, where this information becomes available to anybody now after this one. But what about the geospatial data? So let's see what is happening, or something that is happening very, very recently, in my opinion. Something very similar to the print press, the invention is happening right now in this era that we are living right now. So let's say if you like to collect some geospatial data set, the way how it used to work is you need to have a big airplane, helicopters, or even if you're going to go even large scale, you need to have a satellite. And there is no way, as an individual, you can afford to have big airplane, helicopters, and satellite. Not alone, you need to have somebody who is going to manage this kind of resources. Plus, you're going to need some. You are not just flying it. You are just carrying some form of sensors so that you can collect geospatial data, so that you can turn this into some kind of information that you can use. So this itself is a very, very serious investment that needs to happen. So this is the reason why this geospatial data generation was very, very limited to small group of people. A lot of times this is a big engineering firm or federal agencies like in the NASA or European Space Agencies, they can afford to do this. But this kind of technology is great because this provide a lot of crazy stuff. This is one example of space telescope that is operated by NASA. And we started at kind of very far away, but we are almost kind of zooming into very small section, almost infinitely. But if that happens, you're going to see something that is showing in the center. This is one of the nebulas where all the stars are being created. There is no way we can see or observe this kind of stuff on the ground without this kind of technology. And this is images that is collected by NASA Hubble telescope a couple of years ago. And this is how it looks like in high-resolution images. And now we have a new telescope in operation, which is James Webb. Probably you might have heard of it. And they took image of same location with James Webb. And this is what they see now. It is exactly the same, but there's a lot of other stars that was not visible before. So again, I'm talking about seeing the unseen. And of course, NASA spent probably billions of dollars to collect this kind of information. But as an individual, we cannot afford to do it. Same analogy as before, text information, you need to have a lot of money to generate. But with this new technology invention, that cost went significantly down. Turner clock, probably, I know some of you in this room are operating drones. Now, the same kind of the high quality geospatial data set can be easily generated by drones. And this is an example of my research group Joshua. He's collecting LiDAR imagery from the DJI drone that you can purchase. And in old days, if you like to collect LiDAR data, you have to easily pay millions of dollars, of course, in a very, very large area. This platform itself, depending on what kind of configuration you get, but if you go kind of bare minimum, it will cost you a little bit more than $20,000 to get started. So comparing millions of dollars, $20,000, and this price is going down every year, right? And if you're talking about not LiDAR, more kind of conventional sensors like an RGB, go to Walmart, Best Buy. You can buy DJI drone, a little bit more than $1,000, and that drone generates a beautiful, high-quality geospatial data set. So you see the analogy that I'm making here? Text information was only for a small group of people who had power to do so. Geospatial data set was the same. As an individual, there's no way you can create this kind of high-quality information. Nowadays, I know I'm not saying that $1,000 is small, but this is an entry to be a geospatial data content generator is a lot lower than before. And this is something that you can do. I'm trying to mimic what I showed NASA did earlier. Of course, this is DJI Phantom, I think even 2. A long, long time ago when I was in Texas, I took this video. I'm trying to mimic almost infinite zoom. Of course, not at the same magnitude as NASA is doing. Well, you got an idea. But this is just a $1,000 drone. They can do something like this. There's a lot of detail that you're not able to see. But by getting close, there's a lot of information being generated. But one of the, this technology is great, but one of the biggest problems of this technology is that it generates a lot of data. And sorry I cannot ask question for the online audience, but probably you can answer that question in the chat. But in this room, how many of you have any issues with managing this drone data set? Because this drone data set, we can easily generate hundreds of gigabytes in a month or so, right? We have a huge amount of data set. Unless you have a data set or something like this, managing this data set is not that easy. And a lot of times, the way how it works is that, hey, I'm going to store this in my external hard drive, and I stored this 5 years ago. Oh, where did I save it to? Unless you have a very well-structured folder structure, finding data set is not that easy. Okay? So that's the reason why we developed this open source project called Data to Science. So main idea of this open source ecosystem is that we have big data. We like to turn this data into something so that the scientists can use this data to to make advances in their own discipline. You can just manage all this drone data set on a website. You can visualize this in images. And you can also visualize in the 3-point cloud data set as well. And what I like to do is that I like to have a quick demonstration of this platform. I'm going to exit out of my presentation. And this is in a website. The URL for this website is called ps2.d2s.org. And D2S stands for Data to Science. And the PS2 stands for not PlayStation 2. It is a Plan Science 2.0 initiative, because a big chunk of initial seed funding coming from Purdue School of Ag in a Plan Science 2.0 initiative. So that's the reason why we named it as PS2. Okay? And this website is open to public. Anybody can create an account. For example, I'm already logged in, but if I sign out, this is going to be the landing page. If you already have an account, you can click sign in. If you don't, click sign up. Put your name, your email, and your password, and click create an account. And you'll have to confirm your email address, because this will be used as a way to recover a password if you forget. And we will approve your account as soon as possible. But sometimes, we don't want this to be kind of automatic, because we don't want any bot to create the hundreds of accounts automatically. And sometimes it may take time. I think we have a group of people who is approving this account. So usually it is in a very instant. But sometimes I get an email, especially from Europe, 3 a.m. in the morning. I got an email saying that, hey, I created an account an hour ago. It has not been approved. Of course we can, because we are in sleep. So in those cases, it will take some time, but in most cases, especially in North America, if you sign up, your account will be approved in a few minutes. Okay? So create an account, then once you go to login, you can just click here, put your name and email and password, then you can log in. Then you will land on this home page where you have access to whole project. So you see all those numbers here. These are the number of projects that is available in a specific region. So if you know the area that you'd like to go, for example, I like to go to Purdue West Lafayette area. As you zoom in, you can see that there is more project. The markers become available. Once you click this one, you can open up this in a specific project. But also, if you know the name of the project, I just type in Tipitini over here. Then it will filter by actual the keyword. It will show up the project card available over here. I'm going to click this project. And this is the data set my research group collected actually last year as a part of the XPRIZE rainforest competition. And this is one of the most remote area that we collected our drone data set. And let me just zoom out. This is in Ecuador. And to get into this remote location, it took us actually 3 days to get there and 4 days to get out. And the first thing, orientation that we got as soon as we arrived there, orientation, the staff member was telling us, don't get sick, because the closest doctor you have is 9 hours away. So it is in that remote area. This is about 2,000 acres. This is one of the largest, the drone flight that we have done. And as you can see on the left, these are all the flight. There's lots of flight. But let's say I like to see orthomosaic images that we collected over this area. I just clicked it. As soon as I zoom in, you're going to see these high resolution images being generated. Then you're going to see all those individual tree crowns can be visualized as well. And this image file itself is about 170 gigabytes in size. And what I'm doing right now is I'm streaming this information to this web browser. And the way how it works, I'm not going to go to the technical detail. We are streaming using taking advantage of cloud optimized data format. So like you guys are watching a video on YouTube, you never download the video. You're streaming. Only portion they're looking at is being streamed to your browser. We are doing exactly the same thing. Original file is about 107 gigabytes, but you're only looking at a small portion of the area. So they are only streaming those small portion of the area at the resolution that is needed to display this file in the browser. So that is what is happening. So also zoom out, go to the other corner. I'm going to zoom in, then you're going to see high resolution images being landed at the same time. Not only we can visualize this in the rest images, we also have LiDAR data set being collected over here. If you click this in LiDAR data, Let me just increase the number of points that I can visualize. Then let me just zoom into one of the trees over here. As you can see, all those details about trees becomes available here. We can just do the 3D visualization as well. And what I'm showing here is that the only small fraction of the project that I have an access to. Let me just filter this out. Let me just go back. Go to homepage, and as you can see over here, I have an access to about 341 projects. But for me to find the project that I need, it's very easy, because if you know the location, zoom into the map by clicking this project, or you can just search by keyword. For example, I have Cornell wheat project that I have in the data set, search by keyword. For example, I'm gonna click this in a specific orthomosaic images. We also can handle vector data sets. So this is the actual plot boundaries of this trial. As you can see, you just showing over here. I can use calculate the different vegetation indices. Then we can overlay this by clicking it. We're gonna do zonal statistics of this specific plot. So this is just scroll down here. Zonal statistics of EXG value for this specific plot. Mean value is negative 0.11, maximum is 0.53, average is 13, median is 10. Then we have a standard deviation of 0.1. All those information is dynamically calculated at the same time. And we also have other kind of advanced capabilities to do zonal statistics for the whole field inside this web browser as well. So going back to my presentation here. So we developed this in a website. Like I said, open to public, anybody go create an account. You can upload your data as much as you want as of now, because you have plenty of storage. And this is free, and easily manage your data set. Sorry. But I like to go one step further. Being able to see for the first time is great. Like you see over here, let's assume that you're a musician. I love music. Listening music by yourself with your headset on is great, because it's such a great experience, even especially with the state-of-the-art headset that you got. But even better is when you can share this music with others. Imagine that you're the DJ at the stage. You created something phenomenal you're so proud of. Then you can share this music with these crazy people out there. This is going to be great. Same analogy. Now you have a capability to create something phenomenal using your drone, geospatial data. I can easily spend hours and hours looking every single corner of the field that I never reached to in the field. But now I can virtually go to that location and see all those detail. Even one of the most extreme cases that I experienced is that we had a project that we need to fly drone over the neighborhood. Of course, we got a permission from the homeowners association, so everybody knew we are flying. We collected the data, generated beautiful orthomosaic images, 3-point cloud, etc. While we are reviewing this data, we saw something very, very weird. And we checked the original images that is collected. There is a guy in his backyard has his shotgun pull out, pointing at our drone. I never knew it is happening. But those kind of small detail, you can easily spend hours and hours looking at every corner. You don't see it at the time to collect the data, but this is great. But even better things if you can being able to share this with others. So seeing the unseen is great, but how can we share something that you created with others? Okay, and this data to science platform, the sharing this data set with others is very, very easy. I'm not going to go through how you can do it, but I want to show you what I showed you earlier, and I updated my presentation a little bit. The way how the old way of data sharing. This is some of the slide that I made earlier for another presentation, because this wasn't how Indiana airborne lidars data set was being shared with all the Indiana agencies. So let's say you have a big chunk of geospatial data. The easiest way to do it is store all these data sets in an external hard drive, ship it to some central location, and somebody's going to send out an email. Hey, I got this in a great data set. Who needs it? Then somebody's going to, hey, I need access to this data set. And what's going to happen? They're going to ship it, this an external hard drive to Fort Wayne. Then that person will receive the hard drive. They're going to copy to their local machine and ship it back to Indianapolis, going all around the state. Then they're going to come back to your location. Raise your hand if you have done something like this before. I've done so many times, right? A better way of doing it is that, I don't need to ship it. I'm going to upload it to some central server. Then you're going to send them login information so they can log in and download it. And that's one way of doing it, for sure. But let me see. My clicker is not working. These days, with all this new technology, you don't have to do that anymore. And I know there are some of you in this room, see a lot of younger generation. You guys think of Netflix as a kind of streaming services. But in old days, I know David is sitting here in the back. You know the old days of Netflix and how it works. You have to go to some place, Netflix place, and you're going to check out the DVD. Take this in a DVD, physically in your home, put it into DVD player, watch it. Once you're done watching, return it back. A little bit more advanced version of this sharing system is that now you don't need to go physically there. Go to the Netflix website. Say that I needed this DVD. That will ship the DVD to your home. You just watch it, ship it back. That's exactly the same model as the one that I showed earlier. But these days, we don't do that anymore, because you don't have to download anything. You don't need any physical media. Now even you don't have to download anything. You can stream all your data set to whatever the media or the player of your choice, so that you can consume those kind of information. This is the Google Trend search. It's just only showing 2004 all the way up to 2011. Of course, in 2004, this physical media was a lot more prevalent than YouTube. I think YouTube started sometime here 2005-ish. And as you can see, we had a golden crossover here. Since then, there's no way back. And same thing over here. Text information, we started from handwritten text information to the printing press. These days, everything is digital. Now, you don't need to go to the bookstore to buy a physical book. You can buy ebooks, Kindle, right? You have a Kindle, that I own. I have thousands of books in small device that I can access and everything. YouTube has a 98% market share in media players and streaming platform. This is a scary number if you guys in business. I've never seen any other monopoly other than something like this. Because for me, if I have a video content, I don't even think about where to go. I just go to YouTube, upload it there, and forget. I know how easily I can find this in a video later. This is a guy who has the most subscriber. I think this is the stat that I got last year, so probably he might have more. Probably I see some Indians here over here. This is very, the famous, value channel, right? T-Series has a 263 million subscriber. Who is the biggest media company here in the United States? Maybe ABC, NBC, CNBC? Do you know how many subscribers those channel has? Go look it up. At the most, 10 million. This guy, of course, he's not a single, he has a company. But this channel has 263 million subscribers. Then now, who has more power? Is T-Series channel or NBC? In my opinion, he has a lot more power than those in a big media group. Because these days, I don't watch TV anymore. If there's a news that I need, I just go to YouTube, search it, and I found most recent information right away. I'm from South Korea. You know that we had a martial law incident happen. Do you know, I mean, that there is a YouTuber who went to the place and they were doing live streaming when it's happening. All the soldiers with the guns is coming to this in the National Assembly. He live streamed everything. All those in a big media group in South Korea, they were never able to do so. Anyway, what I want to do is that I want you to pull out your smartphone, scan this QR code, and if you do so, then you're going to be able to see what I showed you earlier. Tip teeny by devastation the orthomosaic images, which is about 170 gigabyte. I'm sharing with you 170 gigabyte orthomosaic file via QR code. David, give it a try. You have a smartphone, right? Scan it. And the even better thing is that you can zoom in and out. You can go to any corner. I'm sure there is a lot of online audiences doing exactly the same thing. I'm not sure how many people in the Zoom. I did this test drive with hundreds of people, accessing this in 170 gigabyte file over this QR code. Every time it works smoothly. Now, whenever you create some the online document, you never send a file via email anymore. You send a link to other colleague so that they can click the link, they can open the document, they can either edit the document or read the document. No matter how big those documents are, you can send this in a file over the via email via link. We can do exactly the same thing for this geospatial data. This is not going to work for your smartphone because a smartphone doesn't have a strong enough GPU. But for the Mac users, if you scan this QR code, I know that you can send this link to your Safari or browser. Open this up, you're going to be able to see that 3D point cloud that I showed you earlier. So I can share the tens of gigabyte of point cloud data set in the form of QR code, essentially in the URL. So I talked about the seeing the unseen. That is great because you can create something without relying on others. It gives you independence. Being able to share this great creation with others is even better. But now, as a research scientist, not only you want to be able to see something, not only you like to share this something with others, more important thing is that you should be able to extract information out of this one. So you should be able to analyze the data as well. That is a lot more important than being able to see and share this data set with others. So I'm not going to go through all those technical detail how this is being implemented in our data science ecosystem, but essentially we have a database over here. There's some modular process that we built in to this ecosystem. But everything that I'm showing you over here is modular. You can pull this out. We can replace it with others because everything is open source. And general users is going to be able to access this all the project through the web browser. So this channel is the one that I showed you earlier. But not only you can do this, we also have a Python module called the Data to Science Pi, or I like to call it D2S Pi because it's a little bit easier to pronounce. Every data set that is on this data to science storage is accessible through the Python module. So now you don't need to download it. Link that with the other open source project. We start working with Plan CV group from the Danforth Research Science Center, and linking this D2SPI with the Plan CV so that you can do all those phenomic extraction. There are many other open source library that work with the data to science. Field Image Pi is one example. This is a Field Image R, initially known as, but they also have Python packages. So once we can load the data set in Python, basically any open source Python library is going to be right next to you. LeapMap at GMap is another open source project to deal with a generic the geospatial data set. GMap is basically any Google Earth Engine data catalog is available for your fingertip. Google Earth Engines. We also have QGIS in a plugin where everything that I showed you, you can stream into QGIS platform. Not only that, we also have in a stack the repository for our own data science. So we are working on a process where you can publish your drone data project to a stack repository so that others can discover and use for their research as well, if there's something you'd like to do. One thing that I'll make sure that you are aware is that the data that you upload to this data science is yours. By default, it is only available to you. No one else can see it. Even I, as a system admin, I cannot see your data set unless you share it with me. But if you decide to publish it or share it with others, that's the moment when it becomes available to others. And there, one step further, you can publish into public repository where others can come in and discover. Good thing about this tech is this becomes almost de facto standard when it comes to sharing or making available your geospatial data set available to others. And there are many other stacks. And the BreedBase is another stack, but this is a genomic database that is operated by Cornell Group. But we do work with them so that we have a drone data set managed by data science, but all the other field layout information is managed by BreedBase so that we can link those two information together. Google Earth Engine data catalog that I mentioned before. Most of the satellite images are also available as a stack. For example, NASA has their own stack services. European Space Agency also has stack services. So you can programmatically query, hey, give me a satellite Landsat or Sentinel image over this location from January of and this year. Then you're gonna get the query return. Then you know how to consume that information inside the catalog. We have a national geospatial data. One good example is the USGS Street App, which is an airborne LiDAR data set that is covering whole United States, that is available as well. Everything's cloud optimized. USGS NAP imagery, National Agriculture Imagery Program data set is also available in the form of a stack as well. So good thing about this is that using this infrastructure now, you can come up with your own modular processing pipeline. The one that I'm showing you over here is already built-in, baked into our data science ecosystem. But if you don't like any of this, you can easily pull this out and plug in your the pipeline to do whatever you want. Because this gives us a very flexible environment where you can mix up other the resources that you got. That's what I mean by modular. And eventually we're gonna be able to publish into stack later. So what I want to do is I want to do a quick demonstration of this data analysis and capabilities. So let me start with a QGIS. Okay. So in QGIS, and we have a plugin that we published. If you click in Imagine So plugin, go here, search for D2S, then you'll find this D2S browser. So it's just all matter of find this in a plugin, click install, and it become available. I'm not going to install because I already have installed that one. Close it, and if you go to plugin, D2S browser, click this one, then you're going to type in what is the URL of the instance that you're working on, what is the email, what is the password, click login. Once you do so, now all those 300 projects that I showed earlier is available over here. Let me go to the Tiptini example that I was showing. Once I choose this specific, I hope I still connected online. Give me a second. Am I? Yes, I am. Oh, this is danger of live demonstration. Let me just do it again. QGIS. I'm gonna do plugin D2S browser again, HTTPS, PS2, D2S.org. Oh, I don't want to expose my password. Is there any way I can you block my screen for a while in the back? I don't want to expose my password because this is a very powerful account. People can log in as me. Oh, okay. Thank you. Give me a second. Oh, thank you. Now you can put it back. Hopefully somebody didn't take a photo of my passport in this room. Click login. Then now we have all this in the project. I'm going to go to teeny one that I was talking about. Now we have all the flight available here. I'm going to choose this in a specific flight. I have ortho and DSM. I'm going to choose both. Add selected map. And just come back out. I just stream about almost 200 gigabytes of images. Keep in mind, this is over the Wi-Fi, right? Then, of course, if I like to zoom in to a specific area, I'm going to zoom into this area. Then you're going to see they are streaming only this section at the resolution that is needed. Then that was the reason why it is so responsive. So I can just turn back. We have the DSM. This is the exact same as in a TIFF file on your local machine, so I can change this in a color map to something different. Click apply, and you're going to have something like this, right over here. And the beauty of this one is that now once you have this available in QGIS, any of the processing capability in QGIS is on your fingertip. The difference is that now you haven't downloaded any data set to your machine. This is inaccessible from QGIS. The other thing that you can do here is that we have a website called pi.d2s.org. This is a website for Python module. All you need to do is, of course, you may want to have create a virtual environment. In the environment, you can install pip install D2S. Then the data science module is going to be installed in your environment. And there's many other resources, but I'm going to give you a quick example here. Let's say I like to visualize a project using a leaf map. Click this notebook. Then we have all those in a Python code available to you. And what I can do here is that this is the Jupyter notebook that can be run anywhere. You can copy this into your local laptop, run it from there. You can open in a Google Colab, for example. Then I'm going to run this code in the Google Colab. So I'm going to install these two packages because D2Spy and LeapMap is not available by default in this Google Colab environment. So they are installing these packages at that specific instance that we are running. Give me a few seconds. Come on. Almost done. Okay, now I can load the module. Then I can log in programmatically. I don't know why it is taking this long to load the module. Okay. Sorry. I can run this code, type in password. Believe me, I don't want to block this screen. Okay, I'm going to show you. You can run this code in Google Colab. It'll work. But the even better thing that I want to talk about here is that we also have a Jupyter Notebook server running on this PS2 instance. The way how you can access it is go to the lab.d2s.org. I'm sorry, this is not available to everyone. This is in the early stage of development. If you need access to this Jupyter Notebook server, send me an email. We will consider your application and activate your services. But basically, you can run this in a Python code inside this Jupyter Notebook server. The difference between this one and the Colab is Colab is a server that is managed by Google. All the data set is in a Purdue data center. In order for it to analyze it, you have to stream all those in a bit to the Google Colab server, which may take some time. This Jupyter Lab server is running on Purdue Data Center as well. So data transfer from the actual data storage to this Jupyter Lab server is going to be extremely fast. So you should be able to handle very large data set processing fairly quickly. And I'm going to give you an example of some example here. This is one of the weak capped trial that I'm part of. They have a whole season of wheat data set being collected. I'm not going to go through all this detail. We've defined some function there. I'm loading lots of modules there, getting a project. You know what? Let me just run it. So I'm going to just run this. And probably I may have to install this in the packages as well. Okay. I'm going to run this code, loading a bunch of modules. And I'm also connect to the project because I already set up the environment. Then getting all the project, choosing a specific project that stores in the vector data, getting all the flight, querying all those RGB imagery programmatically, then getting a boundary layer, and asking what kind of varieties available in this specific experiment. It shows all this variety. I'm choosing TOM 116, for example, as a test. Then showing all those the experiment that include this in a specific variety, choosing this UV-THI trial, running this code, now clipping all those in auto-mosaic programmatically. I already did it, so that's the reason why this is happening so quickly. But basically, I'm just going through this, then visualizing clipped images. Now I'm using a Matplotlib, so you can see the clipped auto-mosaic images available inside this Jupyter notebook over specific the data the planting. I can just repeat the same thing for calculating excessive greenness index and DBI calculation programmatically. Then once you do this, you can see this in the EXG over time can be visualized over here. So the point I'm trying to make here is that you don't need to download any data set. Everything is on the cloud. You can write a program. You know how to stream this information to this environment. You can just develop this in a workflow. You can apply this to many experiments. Even you can share this code with others, then others can replicate what you're doing very easily. Last thing that I want to show you is the stack repository that I was talking about. We haven't implemented these features yet, but we are working on developing a feature where you can actually publish your data set. But we do have other the data collection available in this repository. One example is 3DEP, like I mentioned earlier. This is airborne aerial LiDAR data set available for the whole United States. We have a nape imagery as well. Let's say I like to find the data set around, since we are doing this in Champaign. Let me just zoom into Champaign area. I never searched for it, so trust me, I'm doing this for the first time. Let's say I'm interested in data set around this area. I like to look for 3DEP and also nape imagery. Okay? Click submit. Then they're going to go to the repository. That will show you nape imagery if it isn't available. Show it over here. You see that 2019 Indiana airborne LiDAR data set is available over here. So if you just click this one, you're going to see this is the coverage. If you click this in a copy URL, this is in a URL to cloud optimized data format. Then if you go to Google, COPC viewer, so any platform that knows how to consume cloud optimized point cloud data set, you can just simply add the data, click add. Then this data set will be added to this one here. Let me zoom into campus. Help me to figure out where is the campus. Is this the campus here? Sorry for my. This is the campus? Okay. Let me just activate this. Now, I haven't downloaded any data set, but you have airborne LiDAR data set being streamed from the cloud. Now, what I'm doing here is doing this manually, but you can programmatically query this stack. Imagine that now you have a programmatically query nape imagery, high resolution airborne imageries over the last 10 years, 3DEP airborne LiDAR data set. You can programmatically query all the satellite images, couple that with your own drone data set, they can programmatically access it. Now, you have everything that is available to your fingertip without downloading any single bit of data. Okay, I know I'm way over time right now, so let me just finalize my presentation here. So my vision when it comes to video content, I never think about anyone else. Go to YouTube and upload the data. When it comes to geospatial data, drone data that you collected. Now I'm going to ask you a question. Where are you going to upload your data? Speak it out. Data to Science is a free and open source platform. You don't need to pay any single the penny to use it. Once you upload it there, you can access it. You can share with others. You can analyze the data in any computing platform of your choice. I'd like to acknowledge all the funding sources. The biggest funding, like I mentioned earlier, come from Plant Science 2.0 initiative from Purdue School of Ag. But I do have also other funding sources from USDA as well, which is listed over here. And we do have a website. If you go to the D2S.org, this is our the main website where we're going to have link to the documentation pages, link to the QGIS plugin, Python modules, and what is that, stack, and the link to PS2 instance. We have also YouTube channel. So at the bottom of this page, we have a ton of workshop recordings available. I'm only showing very, very tip of the iceberg, because I'm showing you what we already contribute this platform. But let's say if you like to create your own project, create a team, how to share, how to visualize in different column map, all those kind of details is available in those recorded workshop. And I also like to thank my other team members. Already myself, Minyoung and Ben was introduced. But I also work with faculty from School of Art. You may wonder that why engineers are working with artists, but this whole UI, UX, user interface and the user experience design is complete something that I had no idea why this is so important. But I realized that is actually very, very important, because a lot of operation that you are doing in this D2S platform is very intuitive. A lot of times even you don't need a manual how to do it. And that is thanks to Dr. Cheryl Ken from the School of Art. I think she's actually department chair right now, the School of Art. And also thanks a lot of the Purdue IT support, Jared, Benny, and Nathan. They were instrumental to make this happen as well. So with that, thank you very much for your attention, being here. I'll be more than happy to any question you might have. I think, yeah. Don't be shy. Go ahead.
I have a question about, it's wonderful presentation and I guess like excellent application, like all the thing. So how long was the project, has been running for, like from ideation to the current state?
This development of this data to science platform started in this 2025, 2023 June-ish.
Okay.
So it's been a little bit more than a year and a half.
Oh, that's very impressive. And is everything running within Purdue, or are you using like national cyber infrastructure resources?
So this PS2 instance, everything is running on Purdue Data Center.
Okay.
But like I mentioned earlier, this is an open source project. We have all our source code available at our GitHub repository. And we also have a Docker Hub repository as well. So basically everything is running based on a Docker architecture. So you need to have to create your own images based on source code. So source code is available on GitHub. We also do provide Docker images from our open the Docker Hub repository as well, so they can deploy using that imagery directly without compiling as well.
Okay. Thank you.
Mm-hmm.
We have a question from the online audience. Tushar Gupta is asking, is the D2S plugin available for ArcGIS Pro?
Quick answer is no. Not because we don't want to, but I don't use it as a product. So I don't know how to use ArcGIS. That's the only reason. But I know there is people who needs it. So this is not our one of the top priority at this moment, because first of all, as is not an open source ecosystem, so we are not putting high priority developing something for as a product. But a lot of stuff that I was showing earlier, even though we don't have a plugin, I'm sure ASRI knows how to consume cloud optimized geotipe, cloud optimized point cloud data set. You will have to do a little bit more manual work, but you should be able to consume these resources into ASRI workflow without any that much issues.
Yeah.
Yep.
Hello. Thank you for sharing this platform with us. So, which database do you use to store the data, and which platform you use to store the maps?
Oh, technical question.
Yeah.
So we use a Postgres in a curl databases and a backend database engine. Of course, we use a PostGIS extension because we need to store all those geospatial data sets as well. But we only use the database engine to store metadata. Actual data is huge. There is no way we can pull this 170 gigabyte AutoMosaic into the database. We just convert every geospatial data set into cloud optimized data format. For any raster images, we just convert into cloud optimized geotiff. All the point cloud, we convert into cloud optimized point cloud. But in the database, we store information about where this cloud optimized data file is located in our hot storage structure. Then you can query that information from the database. Once you get the URL, there's a lot of multi-layer authentication that need to happen, because for some reason you got the hand of this URL. If you're not authorized it, you should not be able to access it. So I'm not going into detail of all those kind of authentication part, but to answer your question, all the metadata is stored in the PostgreSQL database, but the actual data storage is happening at the data hardware storage. Yeah.
Okay. Do you have any other questions? Yeah.
Go ahead.
How do you handle the data streaming, the way where you stream just when you zoom in? Do you do that, or is it with one of the packages?
There are multiple layers. A lot of part is being handled by cloud optimized data format. And in the front end side, the file format itself is streaming the data, but the data is sometimes single band layer. We like to have different color map assigned. So for that one, we're using a MapLibre JavaScript library for the front end part. We're using a lot of open source kind of tools to render those images using in a combination with a dynamic tiler. We're using ttiler is in our backend as well. So cloud optimized data is coming in. There's some rendering information to be provided to ttiler. Ttiler is generating those the rendered images dynamically to the MapLibre. The MapLibre is displaying those rendered images to the front end.
Thank you.
There is a question online.
Oh, I think you turned it off.
Oh, yeah. Do you use FTP to transfer data to your servers?
The quick answer is no. We use our own data transfer protocol. We haven't developed everything from scratch, but I think Benny's going to be the one who's going to answer technically correctly. But we are using one of the open source data transfer the services. We integrate into our pipeline. So it is not FTP. It is over the web. So it is in a regular web port, port 80 and port 443. But we have the service daemon running on the server side. Client is sending those smaller patches to server, and they're doing all those kind of checking on the server. And when all the data transfer is done, they're going to combine into a single file, then the process from there. So quick answer is we are not using SFTP. We are using the web protocol to transfer the data.
Okay. Thank you. Okay. Any other questions? All right.
Oh, I didn't know that there's a lot of people in the back.
Yes. Yes, just looking. Okay, there is one more question. Can we use D2S platform for sharing proprietary data?
Of course, like I mentioned earlier, once you upload the data, it is yours. Nobody can see it. Like I mentioned, even I as an OBN, I cannot see your data set. So this is protected information. Once you upload the data, you can decide to share with a specific people. Then you just share with in a specific group. So I'm not talking about how to share these data in this presentation in detail because of the time limitation, but you have an option to share openly to anybody. You have an option to share with only small group of people. You can have an option to share a team member, a team where there's multiple people involved in this team as well. So there is a ton of option for you to do so.
Okay. Yeah, thank you. Well, if nobody else has a question, I would like to just go back quickly to the streaming data and uploading data. And if you can tell us more, like, what are the limits for uploading the data, and also how can we stream? I mean, maybe you've already answered this, but if you can.
Uploading data, there's no limit. And the largest file that I tried is the one that I tested with you, 170 gigabyte. It worked like charm, no issues. And I think I may have to be careful because, once I said that we have unlimited storage, I know people start to upload a lot of personal stuff, nothing related to the drone or just with your data set. You might use this as another Google Drive where you can store all your videos and etc. There's certain protection is happening, so you cannot do that very easily. But my quick answer to your question is uploading data is there's no limitation at this moment. Streaming data part, do you have any specific question or about the streaming, how it is working?
Yes.
So this cloud optimized data format is a data standard that is managed by OGC, Open Geospatial Consortium. So this, in terms of raster data set, this cloud optimized geotype in a COG, we call COG, is, I don't think they are chosen as standard 100% yet, but they're getting very close to be. And the cloud optimized data format, which is in a COPC, I call it in a cockpit, is also becoming the data standard by OGC as well. So once we store those information as cloud optimized data format, technically how it works is that they just generate a bunch of different zoom level, but they store those different zoom level information inside the file. And once you request certain information at this zoom level, they are streaming only those coarse resolution images part of the file over the network. Then you just know how to consume this information to visualize it. Okay. So in the old days, you need to have some form of a geo server that handles all those kind of tiling schemes. But the cloud optimized data format becomes a serverless services essentially. Once you upload it in some place, everything is through the HTTP request. They know how to consume this data set. Streaming this information, using the the HTTP protocol.
Okay, thank you very much.
Yeah, so I want to once more thank Jinha for the presentation. It was awesome. I also want to say to everybody online, we're going to have to close the session, unfortunately. If you want to, you can contact us with questions, and we'll happily pass them on. For the people here in the audience, it's fine if you want to keep talking with Jinha here. But I want to also be respectful to the people behind the scenes. Thank you very much for setting up the Zoom session. So once more, thank you very much, Jinha, for wonderful work you presented today.
Thank you very much for the invitation.